Hello everyone. Today we are talking about Polarion ALM in Aerospace projects, and on the screen you can see the real projects where we worked in the last couple of years, and it is electrical vertical takeoff and landing project where complete aircraft is defined, specified, and especially in Polarion ALM all the specifications are done initially. Then in Team Center, implementation of some parts is described. The second project is about aircraft engines, the normal big turbine engines. It's also very similar setup. There is Polarion ALM and Team Center used together. The specification is done in Polarion ALM, same as quality assurance, validation, verification, change request, and many other processes. And then the design of the engine is done in Team Center. And another project is about hydrogen fuel cell. It's actually the same setup. Polarion is used to describe the system, to do the specification, design, model-based system engineering, and in Team Center there is a 3D CAD design. So let's talk about these projects and also about the theory behind the use of Polarion ALM. What is Polarion? How it is used in majority of projects, and what is special about Aerospace. The agenda for today's introduction, common use and special cases. So common use of Polarion and special cases for Aerospace. Special reports, what do we want to see inside Polarion for Aerospace projects? And small preview, it is review reports, very special way of reviews and checklists, many of them. Number 4, additional concepts and solutions, what else we can use in Aerospace projects in Polarion, and then we will have questions and answers section. So my name is Konstantin Klioutchinski. I work with Polarion for the last 9 years. Before that, I worked in different industries, including semiconductors, Intel and Texas Instruments, Telelogic and IBM. It was doors and SDL. And also I worked a lot in software development projects and in many industries. So ISO 26262 template for Polarion was done by our company, Guarantees IT Solutions. This is for automotive industry. And we did a couple of projects for medical and Aerospace. So introduction to different industries. If we look at the website of Siemens and the section Polarion ALM, we can see many different companies using Polarion. And on the right side, we can see the industries. So there are aerospace and defense alphabetically on the first place, but also automotive, energy, financial services, pharmaceutical, medical devices, travel. They all can use Polarion to manage requirements and application lifecycle management. So this is some examples of industries. You can use Polarion to describe a tractor. You can use it to describe electric van or medical devices or airplanes. And we will talk today about the airplanes. So blue line, blue arrow shows main functionality. You can see it is thick. It has a lot of capabilities, but we have additional colors, additional lines for every industry. There is something specific which we can add or enable in Polarion, and this will make the complete system special and more useful for specific industry. So we can use something for automotive, for example, templates and integrations, for medical, for aerospace, and even for any other industry, for example, financial. So what exactly are these different colors and what makes the difference? The main functionality, let's look at this first. It includes the core ALM features, such as requirements management. This is used by everyone who uses Polarion. Change and configuration management. When you want to change requirements, you need to create a change request. So it goes together with requirements management. Then test and quality management. Usually after some time, you also start to use it to define validation, verification, test cases, test runs. Then issue and risk management. It's very popular now, the risk management, safety, and issues. They're used if something happens in your testing and you have a defect or issue, you want to fix it, and you put it in the system and connect to your requirements. Then, of course, we can use reuse and branch management. If we have our requirements as a document, we can branch it, reuse, and then create a copy of our product, copy of our requirements. And on the right side, there are some additional functionalities such as build and release management. If you have software development, then it is really useful. You can use Agile approach. You just choose a specific template in Polarion, then you get Agile project. Planning and resource management using plans, audit metrics and reports. These are also useful for Aerospace. So actually, let's try to find out what is useful for Aerospace. We definitely need requirements management, change and configuration management, reuse and branch management, test and quality, issue and risk management, audit and metrics. So this is must have. We could use planning and resource management and agile and hybrid project management. So only build and release management may be not needed if we don't do software development. If we do, then software for airspace also will need build and release management. So from main functionality, we take everything and we will use it in our airspace project. And there will be some additional functionalities which will look a little bit better, a little bit later. Um, so the goals of using ILM, it's to go through digitalization. A successful ILM strategy is part of digital transformation, and it is one of the easiest steps to take, and it brings almost immediate results. For example, if you take Teamcenter, you need a lot of resources to install, to configure the system, customizations, and also to upgrade. It's difficult, or say more difficult than Polarion. With Polarion, you install the server in one day, and 2 weeks later you have your requirements in the system, and you already have traceability reports coverage. So it's really fast, and you see results immediately. It is not just about regulatory compliance to use ILM. It simply makes the information management and collaboration better. To have a successful ILM solution means to have the right technologies in place, optimal organizational design, high quality data captured from wide range of sources, and the widest possible collaborative approach. So what does it mean? Well, first, the right technologies. It's not only Polarion what you might need. You will need other tools, and they will be integrated with Polarion, with your requirements management. It can be test management. It may be quality of requirements analysis, maybe simulation tools, model-based system engineering, such as Capella or MATLAB Simulink. So all of these, they define the right tools, the right technologies. Then you need high data quality. So if you take garbage in, you will get garbage out. So you need to find your requirements, import them, filter them, process them, improve them, and then start to use them. You cannot just take standard, import it, and think that the job is done. No, it shall be structured requirements. And Polarion helps to structure requirements automatically when you do the import based on the keywords and on some special logical rules. And collaboration is a big part of the game because you will have many people from different teams and they need to work together on big amount of data and many different projects. So you need to manage permissions, you need to manage who has access. Maybe you have supplier collaboration, someone will have access to your projects from outside of your organization, and you want to share only a specific document, and you don't want them to see some other information. Also, collaboration is import, export of data or round trip. It's also a way to collaborate. So let's look again at main functionalities of Polarion, which we are going to use in Aerospace projects. So for collaboration, there are solutions, user dashboards, comments, approvals, electronic signatures. So when you assign tasks, they can be found by getting email notification, looking at the user dashboards where you can see your assigned tasks. And you can also have many different dashboards to see who is working on what and what is the status. When you want to discuss or review some data, let's say requirements or test cases, then you actively use comments and approvals. You do this inside LiveDoc, and you can also do it for single work items. And when you finish your review process or approval, then you use electronic signature to show that the document was signed by authorized person and now it is in published state. And of course, Polarion is a web-based tool, so everyone works together in the same environment. So it's a great collaboration place. So number two, traceability. Uh, this is about the links. You have documents, you have work items inside the documents, and you want to link your requirements to show the dependency between them. And you want to link requirements to the test cases to see that requirement is tested and there will be coverage. And maybe you have issue or defect, it shall be linked to the test case. So you use the links to analyze the changes. If your items are linked and someone makes a change on one side, then you can see so-called impact analysis or suspect link. There will be a red flag showing you that something changed on another side. Maybe you need to analyze the change and look at your requirement. Maybe it needs to be updated. We can always answer the question who did what, when, where, and why. And this is based on history and traceability. Now, another point is data storage and reuse. We store information in Polarion in work items. Work items could be put in live docs. Live documents are containers where many work items are located. We can put live documents in collections, and we can branch and merge documents or collections. So there are many layers of reuse, and there are many ways how to store information inside kind of containers. So now we can see that for Aerospace project, the default functionality, out of the box functionality of Polarion is already a very good solution. And on the right side, we can see extract from help, which tells us what other functionalities could be used in Polarion. Now, what we are looking for in the next slides is what is special. So this will come after a couple of slides. Let's look a little bit at how Polarion looks like. So this is example of Polarion and also some logical structure. These are first steps what everyone does in any project. You have somewhere outside of Polarion Word or Excel files or maybe text files. They contain requirements, specifications, standards. You want to import them into Polarion to have live document with a structured information, where structured information means you have work items. Information is split into work items. And then you apply workflows, which are shown on the right side. Workflows can be applied to single work items or to the complete document. And they tell you what actions can be done. They check some fields, they check the permissions, and they will allow or not allow for you to do the action, or they can also help to automate some of repeated actions. For example, you can say, I change status of my live document to approved, and then automatically you update work items, you assign them a version, for example, if this work item is also approved. So this is normal way of working. From external documents, migrate to Polarion, apply workflows, and you have structured project. Now, V model is very famous, and it's also applicable to Aerospace. We also have user requirements, system requirements, architectural design, component design development. It's only done slightly different. For example, we have aircraft requirements. Then we have level 1, level 2, level 3 requirements. And then there will be some additional design elements and components going below in the V model. And on the right side, we have validation and verification test cases. So the principle is the same. It's only the names of work items are different. And if we are talking about not only commercial projects, but airspace projects, they are done in regulated industry. And the regulated industry requires strict process management, strict requirements management, well, and of course, strict time and plan management, because you need to deliver on time. So by using workflows, planning, structured data, we can guarantee that our processes will be strict. It will be really manageable project, and we will know the status of our data, including requirements analysis. So this is what happens in any industry, how Polarion ALM is influenced by external regulations, and what we get in Polarion to address these requirements of the industry. So on the left side, we can see standards, processes, and integrations with other tools. Every industry uses different standards. You also use different processes. For example, you want to have SPICE processes, so ISO 26262 related processes for HARA analysis. This is for automotive industry. And in Aerospace, you have DO 178 standard, and it also brings specific processes specific for Aerospace and also the standards. Integrations, well, they could be similar because you still use something for model-based system engineering. It can be Capella or Enterprise Architect. You do simulation in MATLAB. You probably do CAD design in Teamcenter, but maybe you have some homemade integrations with test management tools or with specific simulation tools. And when we apply these external influences from the left side, Then in Polarion, we will create specific templates, specific data model, and we will define specific workflows. And then we will use widgets and extensions. Maybe we will develop some of them to show the data and to help to manage the data in the way how the industry um, likes to see the data. And of course, reports. There will be many specific reports, and we will talk about some of them very soon. So if we compare the projects, then we will see that there are different reports, different documents, different workflows between the projects in different industries. And as we discussed, it is because standards, processes, and integrations are different in different industries. It is impact of standards and regulations. So now this is example of Polarion project. It's just example. It's not really from Aerospace, but it shows what we try to achieve. We have on the left side a document where we store our specification. It is split into work items. We see on the right side impact analysis, so relationship, graphical view of traceability between work items, the tree. And this is what we want to achieve in terms of linking the data and analyzing the relationship between the data. Then we have some special tables which help us to display the data specifically according to some standard. For example, if we do review, we probably want to do review according to some regulations, and we need FME table, we need HARA table, we need other safety analysis tables. And for these, we will define tables which display the link data from the tree in a compatible way, and you can also edit the data. You can see sidebars where you can change the values. And the graph in the background, the round graphs, they show coverage report, how many test cases are linked to requirements, how many test cases passed and failed. So this would be a standard way of trying to manage data in Polarion, and it is applicable to Aerospace from specification to traceability tree, using some special ways to display information and to enter the values, and then looking at the reports to see coverage and some other statistic. So now we are coming closer to Aerospace. There is DO178C standard, and there is a project template available on extension portal. And these standards, they are talking about software considerations in airborne systems and equipment certification, but there are other standards which also talk about hardware design and also guidelines for development of civil aircraft and systems. So if we get the right people in the organization, we can actually put inside Polarion project template a lot of useful information, and we can manage the data. And then we go to the step number 2. We need a custom template. So it can be done by you, or it can be done by us for you. So we take all of these standards, modify the workflows, modify the data model, and then it will work and it will help you to do the job. And now later we will see the real examples. So here we are. Example of work items from a real project. You can recognize here level 2, level 3, level 4 requirements. So there are L2 system requirement, L3 system requirement, L4 item requirement. We have some assumptions, functions, risk for the risk analysis, tasks. There are some system parameters, so we can reuse some of specifications, change the parameters, and then we will have a new branch with the new values for the requirements. It's very useful and saves a lot of time. Interface and wiring information item is just a text, which we will also want to control as a work item. Design description, review, as there are a lot of reviews in Aerospace. Engineering evaluation, test cases, test procedures, inspections, equipment qualification, failure condition, safety requirement, threat condition, problem report, and change request. So this is our system project. And then we have another project which is slightly smaller. It's about aircraft requirements. It also has information item review, inspection, evaluation, assumptions, function, test cases, and so on. So if we talk about Aerospace, there are some requirements or even expectations of the industry. And this is number one, compliance and regulatory management. Aerospace system must adhere to strict safety and regulatory standards, such as those set by Federal Aviation Administration. And requirements management tools should support the tracking and management of compliance with these standards. So to be short, these requirements, they talk about storing requirements in a good way, having these requirements structured, and also having traceability and history. So history is very important. You shall start your data management in a system where you can store the data for 20 years, and you shall be able to go into the history and to see what was the relationship between the data, to generate the same reports after 20 years while your aircraft is still in service. Next one, verification and validation. We need to ensure that the Aerospace system meets their requirements. And for this, we need verification and validation processes. Requirements management tools should support the planning, execution, and documentation of these verification and validation activities, including test cases, test results, and any necessary corrective actions. Well, in Polarion, this is solved using different types of test cases. We can define system test case, we can define component testing, and we have manual test cases, and also we can import results of automated test cases. Test cases are always linked to requirements, and we have full coverage, and we have full traceability to the latest results or to the results in specific test run. Traceability is the king of this requirements management area. So number one is to get requirements right. Number two is to link requirements between themselves and between other influential items. Traceability is very essential in Aerospace requirements management to track the relationship between requirements, design elements, and verification activities. This helps to ensure that all requirements are addressed and validated throughout the development process. So here we can say that traceability tables, it's important. Traceability tables between documents, between requirements, and also review process. Review process helps to ensure that during the review, we detect if any requirements don't have links, if any test cases are without links, and this is fixed during the review, and then we have clean data, which is usable and acceptable by aerospace industry. Version control is the next one. In Polarion, version control is embedded in the system because Polarion uses SVN. So every time you click Save button, there is a new revision which is saved forever inside database. And Aerospace projects often involve multiple iterations and revisions. Version control allows engineers to manage changes to requirements and maintain a history of all revisions, ensuring that everyone is working with the most up-to-date information. Well, there are some tricks about this. If you always work with a third revision, so the latest, this might be not actually always the best, because maybe you need to have a baseline, and this baseline you give to the engineers so they work on a stable data, while other engineers are already working on the next version, and this would be your latest data. And then you create a new baseline and then another baseline, and between baselines you apply a mechanism to see the difference, what has changed. So this is all possible in Polarion. You can compare documents, you can compare requirements, and you can see the difference between the baselines. It's very easy. So there are some other requirements coming from airspace, or let's say they are quite important in the airspace industry. Collaboration, we talked about it. There will be large number of people, multidisciplinary teams, and they need to be effectively collaborating inside the tools and the processes. And there shall be communication and the way to give a comment, to approve or not approve a comment, and then to sign the document and to publish it. So all of this is important to capture requirements, to understand them, to implement them, and also to capture all other artifacts, test cases, design elements, failure modes, and so on. Change management, it's a part of any process when you have iterative actions. Requirements may change during the development process due to new information, customer feedback, or regulatory updates. They happen from time to time. Change management features help teams assess the impact of the change, prioritize them, and implement them in a controlled manner. So in Polarion, you would create a change request, you would link it to some requirements, and then you would plan changes. You would create tasks to update requirements, to rewrite software, to execute test cases. And when everything is finished, you say that, right, this is my traceability. It shows the change request, impacted requirements, executed test cases, and these are the results. So we can commit the change and put it to production. Risk management, it's important nowadays because there are different risks you try to manage and to address. There are risks which are coming from your design. For example, safety of the aircraft, it was always there and it was always very important. But now there are also cybersecurity risks. You need to do threat analysis, attack path detection for cybersecurity. And you can also do risk management of a project itself. Do you have enough resources? Um, do you have the right equipment? Maybe there are some political or some other instability in your project, and this is important part to address to finish your project. But of course, in the center is safety analysis for the airspace. And airspace projects often involve significant risks such as technical challenges, cost overruns, schedule delays. Requirements management should include features for identifying, assessing, and mitigating these risks throughout the development process. And the last point, not the least, is reporting and analytics. You can have all the previous features and they can work pretty well. But unless you have nice and quick reporting tools, it would be difficult to analyze so much information generated on the previous steps. So Polarion gives you live reports, which help to create report pages for anyone in the company, for management, for quality assurance engineers, for requirements managers. You can have effective reporting, and it will show you what happens right now. It can show you what was happening during the time before, and you can see the trends. One example is how many requirements did they have 2 months ago, and what was the status of these requirements, and what happens now, and can I compare them side by side? This is possible. So as summary, after we implement all these items important for Aerospace projects, we will use reports to see the information. And this visual representation is actually what we need from the tool. We will use traceability report, requirements overview, requirements coverage, cybersecurity report, and documents overview, and many other reports for the history analysis, for impact analysis, relationship between items, planning, resource planning. All of this is possible in Polarion. Now we will look at something specific for Aerospace. This is example of a review, and out of the box in Polarion, we can use a review mechanism using comments. So we can comment any part in the live document, and we can make comments inside work item, and then we can close comments and have a summary of these changes. We can also do summary between particular revisions, but it is still not enough, because in Aerospace, there are many questions which look like checklists. And on this picture, we can see that we have one requirement. It's a blue item in the top left corner. They are all located, 3 requirements located in the live document. Then we have review item, and review item contains a checklist. And this checklist will be similar for all review items, but we need to go through every item in the checklist and to answer yes or no. We cannot leave it untouched. This is not acceptable in Aerospace. And in our case, we have checklist with the questions: is requirement atomic, correct, traceable, complete, unambiguous, consistent, verifiable? And the picture in bottom right corner shows us example, a purple color Ref 147. This is our requirement. It's called test 1. And below we have our review item 156, and it has multiple checklist questions, so 7 questions. Some of them are answered, but one of them failed. And because one checklist item failed, the complete validation of this review failed. And that's normal in Aerospace. You do a lot of reviews, and everyone needs to be very precise about answering the questions. So in this example, what we can see is requirements are in LiveDoc. We have configurable checklists. We can define what questions are there, and we can see statistic per document. And this will be on the next page. We have now a similar item on the right side, but on the left side, it is complete live document with multiple requirements. They are purple color on the bluish background. And below every requirement, we have review item. And we can see that some review items passed and 2 of them failed. And above, we have a summary, how many reviews failed, how many passed, and also review items by results. If you have a document with many work items, then this is a great way to see the summary, to distribute reviews to different people. They will do the job, and you will look at the summary before you approve and sign the document. And this is a special functionality which we developed in our company, Garantis IT Solutions, and this was already used in a couple of Aerospace projects, and it was very successful. Another special solution, MRL, manufacturing readiness level. So in this case, we will use very special example of a so-called party cake. We are making a chocolate cake, but in reality, all of these items are parts of the aircraft. So we have a commodity. Commodity is part of the aircraft. For example, a wing, a battery, aircraft software system, chassis, and each of these items, they have also special checklists. They need to be checked if they are ready for manufacturing. Do we have right equipment? Do we have the right technology? Do we have proof mechanism, testing and validation? Do we have the blueprint in the right format? And so on. So in this case, again, we use a live document as a container. You can see it in the middle. And then we define all of these aircraft items, systems, and below we have automatically generated from a template checklists, checklist questions. So here they're called melting chocolate, mix dry ingredients, cream the butter and sugar. Instead of that, you will say, well, prove that your win is very reliable. Maybe do some stress test, maybe do icing test. How is it in low level temperature? And what is the simulation results? And what are the items you need to assemble? And do you have the assembly line? So all of these questions you put to every item of your aircraft. And then the table on the right, it shows you summary table. People will answer the questions. You can do this review from time to time. Maybe 3 months later, you have a different, better results, and you certify for yourself that your aircraft or particular system has subsystems and they are ready for manufacturing. So this is also functionality which was developed by Garantis IT Solutions. It was very successfully used in a project and people are very happy. And the funny and interesting thing is that we did this example with chocolate cake and it was only 10 items in the questions. And in real projects, there were hundreds of questions. And then we need to do redesign of our solution. Polarion was working fine, but administration of these questions was difficult. So we did some improvements and now it is working with even hundreds of questions. So that's another view of the same document. So how to implement Polarion? If you want to start your Aerospace project, you need a plan not only related to Aerospace industry, you need a plan related to how you will roll out Polarion, how you will put the features and functionality to the practice and get your team working in correct way. So we usually use Agile approach. There is a project kickoff. You can see it on the left side at the top. Then we have workshop introduction. So we talk about different functionalities. We explain to the key users, to the champions in the different groups inside your company, what is possible. And it's more like a dialogue. People can ask questions and we will show examples of how some functionality works or what can be the approach to address particular need of the people, of the users. Then whatever you deliver, it will be used by the people in the real project, but you probably will have prototyping. You will do proof of concept of some feature which did not exist. So we develop customizations, we developed for the processes, we develop customized widgets, and we give them to some users, do prototyping and proof of concept, get the feedback, and then we provide MVP, and then after testing it is ready for production, and then the agile cycle happens again, and it happens again in parallel for different functionalities. So here we can see there is functionality number one. There was some idea or need of the company. We go through the agile process and we get development and deployment to production. And in parallel, there is a different group of Polarion consultants from our company working on another functionality. We talk to each other, we talk to the users in the company, making sure that these two functionalities work together very well in production system. And then functionality number two is deployed to production again. So we also have blue items on the right. This is what you need anyway in any system. You need server maintenance. You probably have Polarion as on-premise, or you can also go in the cloud as a SaaS, or you can use Polarion X. So whatever you choose, you need to maintain and manage the server. Then you need first line user support for your users. They cannot click the button, something doesn't work, they don't have access rights. This is first line user support. Project configurations, this is for administrators. It's constant. Of course, you can create a project and people can use it for half a year. But during this half a year, they obviously will have some requests. And you will, in the background, you will configure changes in the project, in your development environment. You will show it to the users. And when it is ready, you will deploy it to production. Development, that's part of project configuration, but it might be more than changing configuration of XML files. Development, it can be new plugin, it can be new widget, it might be even integration with another tool. And concept solutions, this is something big. You try to decide what role of Polarion will be in quality assurance, and how it will be integrated with QA tools, or maybe what is your integration with Teamcenter, who is the master, who is the slave, how the data flows. So these are all the concept solutions. From concept, you move to development, to project configuration. When it's ready, you have first line support, and of course, server maintenance is used to deploy the solutions. So this is how the big project works. So you might have multiple small and big agile processes in your project. This is just example, but on organizational part, there will be meetings, discussions, demonstrations, implementation, and review. And on technical, you need to manage requirements. You need to write them down. It's not requirement for your aircraft. It is requirement for the system, for Polarion, for other integrations, what they shall do, how do you verify, and how do you keep track of what was done. You will do design, reuse, prototype of different functionalities. There will be development effort, testing, of course, integration and deployment, maybe on different servers, on production, on integration, on development server, and there will be review and use as part of a complete process. Questions and answers. You can send questions and answers to our email. You can see it below, info@guarantees-solutions.com. And we will look at one more additional part, integrations. So whatever your Aerospace project is, Polarion will be not enough. You will have something else which needs to be integrated. And here are some of the tools which are on the market and they are used in Aerospace projects. So Enterprise Architect or Capella, they are used for model-based system engineering. MATLAB Simulink, it's very useful and it has integration. even more than one. You might have some test automation, version control, maybe not only SVN inside Polarion, maybe GitLab, maybe Bitbucket. You can have continuous integration, Jenkins, and there are many other tools, and there are quite a few integrations available on Polarion extension portal. If you don't find integration what you need, we can develop it for you. So just tell us what is needed. There are web API, there is REST API, so it's really possible to develop any integration with any system. If we look at landscape of Siemens tools, and especially Polarion and Teamcenter connection, then of course Polarion can be connected to Teamcenter, and there are again more than one integration. You can have OCLC integration, you can also copy some fields, and you can even transfer document from Polarion to Teamcenter as PDF. So it's very recommended to look at these. If you have Teamcenter already, then Polarion will be connecting very well, and you will have seamless integration. And Polarion itself, it's solutions that evolves. There are many different templates. They are developed by Siemens, by partners, by community. So DO178C, it's one of the templates. There are many others. And you can take the existing functionality of Polarion, these are the blue items, and you add the red items from the right side, and it is your choice. You can add as many as you want. You just need to be careful to integrate them correctly. So there can be risk management, improved, enhanced document management, compliance and standards with different standards, cybersecurity, Aerospace. You can use safe and many more functionalities. Thank you very much for listening. I hope that it was useful for you to give you outlook how Polarion ALM can be used in Aerospace projects. For questions and answers, please contact us at guarantiedsolutions.com, and we will be happy to help you.